Have you ever run into one of those problems where they give you a function and they tell you to complete the table with points that lie on the function? Well, that's exactly the kind of problem we're going to be going over in today's video. I'm going to show you an example of how you can fill out the table and complete the points that lie on the function that you're given. And so by the end of this video, you should have a nice blueprint that you can apply to any type of problem like this to figure out specific points that lie on a given function. If that sounds good to you, be sure to stick around to the end of the video. And without further ado, let's go ahead and jump right into it and I'll show you what I'm talking about. Complete the table. Use the resulting solution points to sketch the graph of the equation. So our equation in this case is y equals 5 minus x squared. And here's the table we have. We basically just have these different xy points, and I'll just kind of make this a little bit thicker here so we can kind of see the difference. Basically, we just have these different x values. We need to fill in the y value that corresponds with that based on the equation that we're given here. And then we need to kind of rewrite them as xy pairs, which then we're going to graph. So first of all, what we need to do is figure out the y value that corresponds with each of these x values based on this equation. So to do that, what we need to do is go to our equation and replace all of our x's in our equation with whatever number is in our x row here, and figure out what y value we get out of our equation from doing that. So first of all, if we go to our equation here, y equals 5 minus 2x, or I'm sorry, 5 minus x squared. If we plug in -2, that basically just means we're replacing all of our x's. In this case, we only have one. We're replacing it with -2. So to do that, we basically just get rid of our x here, put in parentheses -2. So it is very important that you put that in parentheses like that, because if not, the negative isn't going to be dealt with properly. So doing that, based on order of operations says that we're going to do parentheses first, which -2 is the only thing in parentheses. There's not really anything to do with that. Nothing's happening in there. There's no operations being done inside the parentheses. Then is exponents. So exponents would be this squared here. So we need to square -2 first. So -2 squared is the same as saying -2 times -2. -2 times -2 is +4. The negatives cancel. 2 times 2 is 4. So in basically the parenthesis and this exponent here are going to simplify down to 4. So we're going to have 5 minus 4, because we still had this negative sign outside of the parentheses, and the squared canceled the negative sign inside the parentheses. So we have 5 minus 4, which is 1. So our y value that corresponds with x equals -2 is 1. Okay, so now we need to basically do the exact same thing with x equals -1 this time. So if we go to our equation, 5 minus x squared, replace the x with -1. Now we need to simplify that. So again, inside the parentheses, there's no operations being done. So the next order of operations operation that it says to do is the exponent. So -1 squared is the same as -1 times -1. -1 times -1 is +1. So everything right here simplifies to +1. So we have 5 minus +1. So 5 minus 1. 5 minus 1 is 4. So the y value corresponding with x equals -1 is 4. Okay. Then we do this for x equals 0. I'm hoping you're kind of getting the pattern here. We really just kind of keep going back to our original equation, replacing all of our x's with whatever x number we're given in this top row here. So in this case, 0 squared is 0. So 5 minus 0 is just 5. Then we replace our x with +1 this time. 1 squared is 1. So we have 5 minus 1, which is 4. And then similarly, we put in +2. 2 squared is 4. 5 minus 4 is 1. So these are the different y values. So now what we can do is we can create xy pairs from these xy combinations. So to do that, we really just kind of rewrite it as parenthesis, whatever your x number is, so -2, comma, whatever your y number is, 1. -1 for x, 4 for y. 0 for x, 5 for y. 1 for x, 4 for y, and 2 for x, 1 for y. So now we have these 5 different xy pairs here. And now what we can do is graph them. So to graph them, all you need to do is start out by drawing your xy axes. You want to get these as close to straight lines as you can. Obviously, that can be tough sometimes when you're drawing by hand. And then we want to label our horizontal axis as x, our vertical axis as y. That's kind of the standard way that you'd label your axes. Then we just want to kind of number them a bit. I mean, it doesn't have to be perfect, but we can see that all of our x and y values are between -5 and 5. So I'll just go up to 5 here, -5 over here. Our y values are all positive. So we don't even need to go down to the negative numbers, but I'll just go up to +5. We could definitely label all these. Whoops, that's not a 4. We probably don't really need to, as long as it's kind of clear that we're going by ones here in every direction. So I'll just label 5, -5, 5, and then you can see each tick mark is 1. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. And then of course your axes are 0. So basically the y-axis is a 0 x number, and then your x-axis is the y value of 0. So now, to graph these points, what we want to do is, looking at our axes, that'll basically tell us what number x and what number y we want to go to. So for this first point here, -2, 1, since x is your first number, y is your second number, we have x -2, y is 1. So we just go to -2 on the x-axis. So the x-axis is horizontal. So we go to -2 on the x-axis, which is right here. Then we kind of just imagine a vertical line basically going up and down all along that. Okay. Then we go to +1 on the y-axis right here. And you can just kind of imagine a horizontal line. If I can even draw a horizontal line going all across there. And then the point that we're trying to draw is just going to be wherever these two lines intersect with each other. So right here, x equals -2, y equals +1. We have this point right here. Okay, so I'm going to get rid of these lines, clean that up a little bit. But right here is going to be x -2, y 1. So that's going to be our first point right here. Okay. So then for the second point, -1, 4, we go to -1 on the x-axis. So keep in mind, whenever you're graphing points or graphing a function like this, you're always going to move left or right first, and then you're going to go up or down from there. So the x coordinate will always be the first one listed. That tells you where you go on your x-axis horizontally. Then the y coordinate, the second number, will tell you how far up or down to go. So -1, we're going to first go left and right. -1 is to the left, the negative numbers. So we're going to go to -1 right here. Shouldn't draw that point. That's not where our point is. But our point is going to be somewhere above this yellow dash here. Okay. Then we go to a y value of 4. Since that's positive, we're going to go up 4 units. 2, 3, 4. So right here is our second point. X equals -1, y equals +4. Okay. So then we have 0, 5. So whenever one of those numbers is 0, that means you're going to be on one of these axes. So since the first number is 0, first we go left or right. Well, if the first number is 0, we don't go left or right at all. We just move 0 units. So we stay at our y-axis. Then we're going to go up or down from there. Since our second number is 5, that's positive. We're going to go up 5 units from there. So up 5 units on the y-axis puts us right there. Then we're going to go 1, 4. So 1 unit right, left or right first. Since it's a positive number this time, we're going to go 1 unit in the positive direction. Then the second number is 4. We're going to go up 4 units from there. So up to y equals 4. Put our point right there. And then lastly, we have 2, 1. So 2 is our first number. We're going to move left or right first. Since it's a positive 2, we're going to move 2 units to the positive direction. So that puts us right here. So this point is going to be somewhere above or below this dash right here. Our second number is +1. We're going to go 1 unit up from there. So then we have that. So once we've graphed all of our points, if we were to then try and graph our full function, so we're trying to sketch a graph of the equation. So we're trying to sketch a graph of this entire equation. Of course, we have these 5 points right here, which we have graphed here. Once you've graphed your points, you kind of just want to connect the dots from there. So if we connect these dots, we're basically going to end up with something that looks like this, a nice downward facing parabola here. We could have kind of taken a little shortcut knowing it was going to be a downward facing parabola because we have a polynomial or a quadratic equation with the x squared term being a negative number. So since x squared is the highest degree within this polynomial, it's a second degree polynomial, the highest power of x. That tells us we have a quadratic, which means it's going to be a parabola shape like this. And since that term had a negative sign in front of it, that told us it was going to be a downward facing parabola, like this kind of a frowny face shape. Knowing how to complete a table like the one we just did is definitely something that you're going to want to be comfortable with. But there's another type of problem that you need to make sure you know, and that is if you're given points and you need to figure out if they lie on a function. So basically go in the reverse order of the problem that we just did in this video. Fortunately, I have made a video on this topic. Just go click on that video right over there, and let's keep this brain train rolling.